All right, target 68 is solving for x in logarithms. So for this, you're probably going to want to have a calculator handy. I'm sure that's going to help. The idea behind logs is that they are inverses of exponentials. So we're going to be looking to put exponents on these and or undo them with that exponent thinking. So here goes. The first one has log base x. There's an x down there in the base. When there's an x down there in the base, then what we want to do is we want to get rid of that. So what we're going to do is we're going to put a big x on it. And now we've made both sides x to the power of. X is our exponential base. Then exponential base x with log base x, those cancel each other out. And 25 equals x to the first power. Well, x to the first power is just x, so x equals 25. And we're happy, and we have the correct answer there. On B, this one has all the numbers on this side already, so there's nothing I need to do. I can type this whole thing in my calculator. Some calculators allow you to do that with the log base key or the log base button. That's found in the math. If you push math and then you go up a couple, you'll see one that says log base, and there is one there that says log base. And if you have that, then you can just type in like the 3 and arrow over and put in the 9 and enter, and you've got the answer as 2. If you don't have that, then we talk a lot about in class that you're going to take at the top of the log divided by the bottom of the log. Basically what you're doing is you're changing it to base 10. Log base 10 of 9 divided by log base 10 of 3 is how we think of it. So then we just use the log button on our calculator and we type in log of 9 divided by log of 3, and the log button is next to the number 7, and we still get the same answer. So there's no difference in the solution, and so we should be feeling pretty good about that because all the numbers were on one side. That one's pretty good. This one now, the x is here. When the x is there and I have log base 7, then I need exponential base 7. So I put a big 7 on both sides. Because if I have exponents like 7 to the third, that's called the base. Okay? And in a logarithm, the base is that little number down here. That's the base of the log. That's the base of the exponent. So in this case, we had log base 7, so we need exponential base 7. And then exponential and logs cancel, and we get x equals 7 to the third power. And 7 to the third power is probably a number that you could know off the top of your head, or not, but it's 343. If you were to type that in your calculator, that's the number you'd get. The next question is log base 3 of x equals 1/2. Now again, this is a lot like that. It's log base 3, so we put a big 3 on it. So then those cancel and x equals 3 to the 1/2 power. 3 to the 1/2 power is the square root of 3, because it's like having 3 to the first power take the second root. The next one is over here, which the x is down here, so I want to get rid of log base x, so I put a big x on both sides. Those cancel. X to the third power equals 27. Then I'm going to take the third root of 27. That's how you undo an x cubed with a third root, so you need a third root of both sides. The third root of 27 is kind of a nice number because 3 times 3 times 3 is 27, so therefore that wraps it up as the third root of 27 is the number 3. The last one here, log base 10 of 10,000. Notice that that's log base 10, and therefore you don't even have to worry because our calculators are automatically base 10, so I can just push log and put in 10,000. Close that out, and it's 4. Remember, every answer to a logarithm is an exponent. That should make sense to you, that 10 to the 4th power equals 10,000. That's really what you just figured out. You figured out the exponent with the log base of 10 of an exponential base 10. So it all works. Anyways, the answer is 4 to this question, and we should be good with working with logs.